For section 4, I'm actually going to split this section into 2 videos because this section covers a lot of content because it does surface area and volume all in one section. So for this first part 1 video, I'm just going to be going over how to find volume of 3-dimensional shapes, and then in part 2, I will be talking about how to find surface area. So let's first just go over what a 3-dimensional figure would be. Most of these you're probably familiar with, right? You at least have an idea of what they would be because you see them all the time without even realizing it. So we have prisms, which would be a 3D figure that has bases that are polygons, and then all of their faces are going to be parallel to each other, and those would be shapes like parallelograms, rectangles, or squares. If a prism is sitting upright, so it's not slanted over at all, so if you think about like a bookcase or a refrigerator or anything that's got kind of that boxy shape to it but it stands upright, that's technically called a right prism. And then we also have in the right prism that the faces are going to be perpendicular to the bases. And again, the faces are like the sides that make up the prism, where the bases are the kind of the top and the bottom. So if you think about a refrigerator, the top and the very bottom would be called the bases because those are parallel to each other, where like the front, so like where the doors would be, and then like the 3 other sides that make up the outer perimeter of the fridge, those would all be your faces. A cylinder is something that has a curved surface to it, and its bases are 2 circles. And again, if that one is sitting straight up, so if you think about like a soup can or like a can that would hold fruit in it, those would all be right circular cans because they have, they're nice and straight, their height would be straight up and down on the can, they're not slanted over at all. The reason why there's a difference here is because we do have something called oblique, and oblique is usually when the shape has been tilted a little bit, so it's leaning to one side, and so it's no longer has a height that's directly on the shape. There's still a height that's in the shape, but you have to look for it because you want to make sure, again, that your heights are going straight up and down, and they form like a right angle degree with the base. You don't want to ever have a height be a slanted side. So like I said, oblique is when the prism or a cylinder, the faces are not perpendicular to the bases. You can kind of see in my pictures there that they're slanted over to the sides. The height of a shape is always going to be the shortest distance between the 2 bases. So again, that's kind of clarifying what I was saying, that that has to be a height that goes straight up and down. You don't want it to be leaning to one side. Volume would be the amount of space that a 3D shape occupies. So different than area, because area would be how much material you need to make the figure. Volume would be like how much can you fit inside of it. So how much water could we fit inside of a pool or something like that. Volume is also expressed as a cubic measure. So previously in the last section when we talked about area and circumference for circles, we talked about how area is a squared unit, and we talked about that too in the first section where we went over like 2-dimensional shapes. But so volume is going to be expressed as a cubic measure. So it's a little bit different when you label. So to find the volume of a prism or a cylinder, the formula is V equals capital B times H. Capital B is talking about the area of the base, so you have to be able to find the base shape that you're working with, and that can change based on what the shape is. And then H stands for the height of your prism or your cylinder. Like I said, the base area will change based on what the shape that the base is. So if it's a square, a triangle, if it's a rectangle, you know, if it changes shapes like that, you will have to use the appropriate formula that we talked about in section 1 that goes over how you find area of a square or a rectangle or whatever that might be. So let's look at some examples here. So I want to find the volume of this triangular prism here. So if the name already has something like triangular, that tells you that the bases are those triangles. And so if you look at the picture, the triangle at the very top has some information labeled. All 3 sides appear to be 3 centimeters, and they do have this 2.6 pointing to this red dotted line inside of the triangle. That's the height because it's got this vertical segment there. Now the 15, that's the height of the prism. So make sure when you're looking at your formula, that capital B times H, the H stood for the height of the prism. Some of your shapes, though, squares, triangles, rectangles, will also have a height that you'll have to use in order for you to find the area of the base shape. So our volume equation is capital B times H. So I'm going to focus first on the base shape. Now, since it's a triangle, the area of a triangle is 1/2 times B times H. This is when it gets confusing because you want to make sure that you guys can understand the difference between the two H's I have there. Inside the parentheses, the 1/2 BH, that's all referring to only the triangle shape. Okay, so the base of the triangle shape is like the 3, because all sides are 3, and the height is the 2.6. The other H outside of the parenthesis, that's referring to the height of the prism, so that's the 15. So I'm going to take 1/2 times 3 times 2.6, that's for the triangle, and then take that times 15. And this, if I round it, is going to be 58.5 centimeters to the third power. If they ask something that's talking about displacement, they're still discussing volume. So that's just a word that you might see in problems referring to how much space is it taking up as you put it into something. So this one wants us to do a cylinder that has a diameter of 5 inches and a height of 4 inches. So volume equation is still B times H. Now, because we have a cylinder, the bases would be circles. So to find area of a circle, we take pi r squared and then times the height of the cylinder. So this is saying that it has a diameter of 5 inches. So remember from the previous section, you'll have to take that 5 divided by 2. So we take pi times 2.5 squared and then times 4 for the height of the cylinder. So this one comes out to be 78.5 inches squared to the third power. Okay, a couple other three-dimensional figures. We have a cone, which would be a 3D figure who has a base that's a circle, and the side surfaces taper to a point. This point that they all kind of come to at one specific area would be called the vertex, or it's also called the apex. So this is what that would look like. A pyramid is a 3D figure that has a polygon for a base, so that, again, that shape can change. It could be a square, it could be a triangle, it could be a rectangle. It could even be something as complicated as like a hexagon, a heptagon, an octagon. A pyramid, though, the faces, like the sides on that kind of meet at that common vertex, those are all going to be triangles. If you have a right or regular pyramid, that means that the base of the pyramid is going to be something like a square. So it's going to have all equal sides, or it could be a pentagon, for example, and all 5 sides of the pentagon are the same length. And then the height would meet the base at the center of the base. So it would come from the very top and it would go straight down to the base shape. So this picture that I just dropped down here gives you a couple different examples of what this might look like. And there's actually 3 different types of pyramids here. The first one kind of has like that blue shaded region on the bottom. That's actually a triangular pyramid because it has a triangle for a base. The middle one would probably be called a regular pyramid because it looks like it has a square. And then the next one would still be called a regular pyramid because, yes, it's got a pentagon down there. But again, if you know that all of the sides are the same, that makes it regular. Now, if it wasn't all the same, then we would just probably call that like a pentagonal pyramid. Again, the vertex at the very top, similar to the cone, that could also be called the apex. And all the lateral faces, if you look at the sides, all of the sides that meet at that vertex point, they're all triangles. A sphere would be like the last 3D shape that we need to talk about. And if you think about any shape that you've ever seen that's like a ball, like a basketball, a baseball, a tennis ball, all of those are spheres. It's just got a big curved surface and all the points are equidistant from the point inside the center. Very similar to a circle. A circle had the center point, and depending on how far out you went, that had points that were going to be the same distance away. But so a sphere is very similar to that. Now we also, inside of a sphere, have something called a great circle. A great circle divides the sphere in half, so it creates like a semicircle almost effect to the sphere. It actually cuts the ball in half. To find volume of a cone or a pyramid, we use the equation 1/3 BH. B is again going to be the area of the base, which can change, and h would be the height of the cone or the pyramid. Volume of a sphere is kind of a different formula. We take 4 pi times radius to the third power all over 3. So again, you'll want to make sure that you're using radius for these problems, not diameter. Alright, for example, find the volume of a pyramid that has a square base that is 15 centimeters on each side, and the pyramid has a height of 28 centimeters. So we're going to use the equation 1/3 times BH. Since the base is a square, to find area of a square, you do side squared. So they have 15 squared for that, and then times the height of the pyramid, which is 28. So we have 1/3 times 225 times 28, which is 2100 centimeters to the third power. Find the volume of a sphere that has a diameter of 90 centimeters. So 4 pi radius to the third power over 3. So since we have diameter, we'll have to put in 45 for the radius because you want to cut that in half. Now for this one, you could do 4 times pi times 45 to the third power. Do that first and then divide by 3. It might make that a little easier instead of trying to use like a fraction at all. So this comes out to be 381,704 centimeters to the third power. Alright, for homework, again, please check the website for the Google Doc. Make sure that you submit your assignment to me via email. And once again, if you have any questions, please feel free to reach out to me.